All right, section 12.2 deals with combination, and a combination is going to be a selection of R objects from a total group of N where order doesn't matter at all. In section 12.1, the order of which we chose the objects totally mattered. Now, if order does not matter, we're going to use a combination. Down here, they give you the formula for a combination with factorials. Honestly, the only thing we're going to do here is use NCR on the calculator. So that's where you're going to hit your math button, and then we're going to probability. You're looking for NCR. So first example, with combinations, we're going to be dealing with a ton of card scenarios. So we're going to use a standard deck of cards. There's 52 cards in it. It says if order is not important, how many different 7-card hands are possible? So from the 52 card deck, we are going to choose 7 of them. Order is not important, so that is why we are using C here. So in the calculator, we're going math, probability, down to NCR, and then you're just typing in 52, and of those 52, we are choosing 7. So we're going to end up with 133,784,560 different 7-card hands that are possible. For this, the next one, they want to know of these 4-card hands, of these 7-card hands, how many of them are of the same suit? So in a deck of cards, there are going to be 4 suits. So to account for that, we're going to choose one of the 4 suits. I don't care which of the 4 we choose. And then we need of those in that suit. Okay, so I chose one suit. Each suit has 13 cards. So of those 13, we are choosing 7 of them. Okay, so this accounts for choosing the one suit, and then of that suit, 13 cards possible, we are choosing 7 of them. So that would be 6,864 possible hands. C, I want to know how many possible hands, or possible 5-card hands contain exactly 3 kings. In a deck of cards, there are 4 kings, so we are going to choose 3 of them. And then since it's a 5-card hand, we need 2 more cards. So there are 48 other cards in the deck that are not kings. We want to choose 2 of them. So we have 4C3 times 48, choose 2. That's going to give me 4,512 possible hands. Example 2 brings into play and or problems. Really the biggie here is that when you see the word and, we're going to be multiplying, or is going to be an addition problem. At least or at most, we are adding up the different combinations that are going on. So putting it into practice, example 2, you go on a vacation. It says you can visit 5 different cities, 7 different attractions. So it says suppose you want to visit 3 cities and, okay, so there's the keyword, and 4 different attractions. We don't care about order on this. So of the 5 cities, we're going to choose 3 of them. And so we have multiplication. We want 4 attractions of the 7. So of 7, choose 4. You go ahead and multiply that out on your calculator, 350. For B, it says suppose you want to visit at least 8 locations. So it's cities or attractions. How many different types of trips are possible? So we want 8 locations. From the cities and attractions, there's 12 different options we have. So we'd have 12, choose 8. And then at least 8 means that we could have 9, or we could have 10, or we could have 11, or we could go to all 12 of them because it was at least. So for that, you go ahead and you add it up. And it's going to go ahead and get me to about 794 different possible trips. Okay, last example we're going to look at. We have a restaurant. They offer, there we go. Restaurant offers 6 salad toppings on deluxe salad. You can have up to 4 toppings. So if we can have up to, we can totally have 4. But up to means that we could have less as well. So of the 6, we could choose 3. We could choose 2. We could choose 1. Or we could just say that we don't want any toppings at all. Again, math probability in your calculator gave to that. You go ahead, plug it in, and it gets me to 57 different possibilities. So that's section 12.